So in this diagram, we are required to calculate the length of OB, which is from here to this point, AE from this point to this point, and then AD, which is from this point to this point. So let me write that down. It is OB, AE, as well as AD. So when we pay attention to the diagram that we have, you will notice that we have got two cycles, the inner cycle and also the outer cycle. We also notice that we have got OD, which is the radius of the inner circle, and we are given that it is equal to 5 centimeters. The other thing that you'll notice is that we have got BE, which is a tangent to a smaller circle. So whenever a radius intersects a tangent, it forms an angle of 90 degrees. So the radius is always perpendicular to the tangent. Another thing that you'll notice is that we have got OD, which is a radius through a smaller cycle. But if we extend the same radius, for an example, all the way to the circumference of the larger circle, then it becomes a radius of the larger circle as well. So let me say this, we introduce a point F. So I would say from point O to point F, we have got a radius. So whenever a radius is cutting across, so let's say for instance we have got a BE, so from this point here to this point. So it's a tangent to a smaller circle, but it is also a chord to a larger circle. So wherever a radius is cutting across a chord at 90 degrees, it also tells us that this side here, or this length, BD, will be equal to BDE. So what we are given here is that the length from BE, which is 24 centimeters. Now because the radius is cutting across the chord at 90 degrees, it means that BD will therefore be 24 centimeters divided by 2, which is going to give us 12 centimeters. So BD will be 12 centimeters, and also DE will be 12 centimeters. Or from our question, we are told to find the value of OB. That means from this point all the way down here. Now that we have established, if this is our angle of interest, we have established the adjacent side and also the length of the opposite side is given. We only need to find the value of our hypotenuse. This is our hypotenuse for triangle BOD. And therefore we're going to say OB or BO, OB squared is equal to OD squared, which is the opposite side, plus BD squared. And therefore we're going to say OB squared, since we are not given, or it is the length that we're looking for, will be equal to OD squared, and we are given that OD is equals to 5 centimeters, so we're going to put 5 centimeters and then square that, plus BD, and we have determined the length of BD to be 12 centimeters. So instead of BD, we're going to put 12 centimeters squared. So OB squared will be equal to 5 to the power of 2 is 25 centimeters squared. So this is going to be 25 centimeters squared plus 12 squared is 144, and then 144 centimeter to the power of 2 is centimeter squared. So the next step will be to say OB squared will be equal to 25 centimeters squared plus 144 centimeters squared is going to give you 169 centimeters squared. In order for us to get rid of this squared, we're gonna have to square both sides. So OB squared is equal to the square root of 169 centimeters squared. So the square root is going to get rid of this exponent of 2, and then we're going to be left with OB is equal to the square root of 169 is going to give you 13, and then this squared will cancel this, so you're left with 13 centimeters. So that is the value of OB. So we have established the fact that OB is close to 13 centimeters. So the next length that we are evaluating is A, from distance from A all the way down to E. So based on what we have, if, for example, this is the center of the circle and this is the diameter of the circle, the angle, if we are going to consider triangle BAE, so this is the diameter from B to A is the diameter of a bigger circle, and then we have got this angle which is going to be formed here, and this angle is always 90 degrees, and the reason being is the angle at semicircle. So any angle that is going to be formed at the semicircle, in as much as all the lines that are forming that are originating from a diameter of the circle, it is going to be 90 degrees. For an example, if we were to say have another triangle B and join it all the way to another EA, and then we call this X, so this angle was going to be 90 degrees regardless of where it was going to be formed at the semicircle. Even if it was formed here all the way to A and then B, it was still going to be 90 degrees. So because this angle is 90 degrees, we are still going to use a theorem of Pythagoras, but we are going to pay attention to A, E, and B. And as you can see, from O to B, it is the radius of the larger circle, and from O to A is also a radius to a larger circle. So if BO is 13 centimeters, it also means that this is 13 centimeters. And then 13 plus 13 is going to give us 26 centimeters. So that is the length of the entire diameter of the larger circle. And then underneath here, if this, for instance, B is our angle of interest, we are going to have an adjacent length of 24 centimeters. So we've got adjacent of 24 centimeters and the length or hypotenuse of 26 centimeters, but we don't have the opposite, which is AE. So that is why we are going to use a theorem of Pythagoras. So a theorem of Pythagoras, we're going to say AB squared, because it is the hypotenuse or the longest side, is equal to BE squared plus AE squared. So AB, we have established the fact that it is 26 centimeters, so this is going to be 26 centimeters squared is equal to BE, it is this one, 24 centimeters plus AE squared. This is the one that we're looking for. So 26 centimeters squared is going to give us 676 centimeters squared is equal to 24 centimeters squared is going to give us 576 centimeters squared plus AE squared. So we're going to take this to the left hand side of the equal sign, so it is going to change the sign. So we're going to have 676 centimeters squared minus 576 centimeters squared is equal to AE squared. So 676 minus 576 is going to give you 100 centimeters squared is equal to AE squared. So to get rid of this squared, we are just going to square this. Centimeters squared is equal to the square root of AE. So this is going to cancel this. The square root of 100 is 10. The square root of centimeters squared is centimeters. So our AE will be equal to 10 centimeters. So a distance from here, or a length from here to here, is 10 centimeters. And so AE is equal to 10 centimeters, and therefore we're looking for the remaining length, which is AD. AD is the distance from here to here. So if we pay attention to the triangle ADE, you can see that our AD is the longest side, so which means it's a hypotenuse, and we have got the opposite side. If D3 is our angle of interest, we have got the opposite side, which is 10 centimeters, and also adjacent, which is 12 centimeters. So all we need is to find the hypotenuse side. So the equation to find the length of AD, which is a hypotenuse of angle ADE, is going to be AD squared, which is the hypotenuse, the one that we're looking for, is equal to DE squared, which is this side, and then plus AE squared, which is this side, AE squared. So AD is not given, we are looking for it, so we're going to write AD squared is equal to DE. DE is equal to 12 centimeters squared plus AE. we have calculated it to be 10 centimeters and then squared. So our AD squared will be 12 squared is going to be 144, and then centimeters to the power of 2 is centimeters squared, plus 10 squared is 100 centimeters squared. So AD squared is going to be 144 plus 100 is going to be 244 centimeters squared. So to get rid of this squared, we're gonna square both sides. So AD squared is equal to the square root of 244 centimeters squared. So this will cancel this, and then you're gonna be left with AD is equal to the square root of 244 is going to give you 15.62 centimeters squared. This is going to cancel this one, and then you're going to be left with centimeters. So the value of AD is going to be 15.62 centimeters, and those are your answers. 15.62 centimeters. Thanks for watching.